I think we can start now. So it's my great pleasure to introduce Paul Zimmermann, who is a long-time collaborator with me as well as a friend. So I took some of his introduction from Wikipedia. Hopefully that's accurate. So Paul's interest includes asymptotically fast arithmetic, computer algebra, and computational number theory. So he wrote the book Modern Computer Arithmetic together with Richard Brent. And he has also coordinated the book Computational Mathematics in SageMath. So I have been collaborating with Paul mainly on contributing to some record computation in integral factorization, but he did more than we have done. So he has contributed to some of the world record in integral factorization and discrete logarithms. He's also the co-author of several computer packages, including the GNU MPFR, floating point arithmetic library, as well as the CADO-NFS, which is an implementation of number field sieve algorithm. Also, our project is Core Math, which is a project on the mathematical functions with direct grounding for the IEEE standard. Right? And today he's going to talk about a letter from Charles or to Charles. I think
to Charles.
To Charles. Okay.
Okay. So welcome everybody. So I do apologize. So the slides are in French, but and too much time. And either I could speak to you about the Core Math project, which is floating point arithmetic, which may be boring for you. I thought this would be more fun for you. So this is joint work with two colleagues from my lab, my team, Cécile Pirot and Frédéric Baudry. Camille Desanclos is the colleague working in history. Okay, so this is the work we did last year. Okay, so this is the letter we deciphered. This is a letter which is at the library in Nancy, in fact, where yeah. And this is so all together there are 4 pages. So there are 4 pages, but one of the pages is mainly the address. So there are 3 interesting pages. The first one is a signature, and you see that it's clear text. It's all the French text, but it's hard to read even for me. So this is okay, so a bit of context. So at that time, so this is Charles V. So he had a huge empire. So his empire on that part here. And the French royaume. So the king at that time was François I, or Francis I, maybe in English. Yes, Charles V was in war. Okay, so at that time, cipher was already well developed, ciphering messages. In each country, told him about the state of the country, if people were trying to develop wars or information. So this information was sensible, so it was better state of crypto analysis at that time. So it's made of several parts. First, every letter, you have different symbols that are 4 different symbols that you can use to encrypt analysis. Does everybody know about frequency analysis here? I guess, okay. Yeah, so all those symbols are to be carded when you decrypt. False will counter any analysis made on repetitions. And if you encrypt the same way, of course, we can see that. But if you insert symbols between the different letters, this will counter this kind of analysis. Name or a word expression. Syntax. Okay. On the French side, the French the same kind. Royals, you see, we have more symbols than for this is what we had. Now we have this letter to decrypt. We tried different hypotheses, knowing what was possible at that time. Try to understand what is a clear text. So the clear text is it starts here. So the first emperor roi, so this means the yes on the king, because it was here that he acknowledged that he had received the letters from his ambassador. So he was writing to his ambassador in France, and received the letters because sometimes the letters were lost or taken by someone else. So in every letter, they write that they have received the previous letter. Just to think that letters could take several days or even weeks to come to their destination. He acknowledged, he has understood what. Okay. Then there is a huge encrypted part, and then it's this part where he speaks about Piedmont here, which is a region in Italy, and it's gathering around Piedmont to prepare some war. Okay. Okay, so at that time, so this is Piedmont. Or the other gathering around this way. Here, the last clear part is this part here, where it just says the 1540. Okay, and the signature of. Okay, so the first time we tried to find somebody who knew how to decipher letters from sharp repeats. And in fact, the guy, Giovanni Soro in Venice, cipher was paid by the Pope, Clement the Seventh. Tells how to decipher letters from Charles V. But unfortunately, we did not find any trace of this book. Okay. We had to try by our own.
How do you know they supposed to take it?
Found some reference to this book,
Oh,
but we did not find it. Found some advice from Philip II to his father. So his father was Charles V. So analysis. So he gave some very good advices. So from symbols for bigram or trigram are very frequent. So group of two are very frequent. A symbol with a dot above, it means a null symbol. So you have to forget about it. And if you have a symbol with two dots on it, corresponding letter should be doubled. For example, if alpha means the letter F, alpha with two dots will be FF. Yeah. Let's back to our letter. Okay. As you can see, there is no punctuation. Don't know when the sentences end, and we don't even know when we really have to find everything. Okay, so maybe you see some things. Maybe you have some ideas. What we did is to count the number of different symbols. For this, you have to identify identical symbols. You see, for example, you see a schema here, which is probably the same amount. Symbols are easy to recognize, but there are some other symbols which are not so. This one, is that the same as that one or not? That one, so we have difficulties quantifying the same symbols or the number of. My colleague Cécile Pierrot did a first pass over all this, and I did a second one. Merge our results. Okay, so what my colleague did is that she gave different colors to the different symbols and to them, and we know. Okay. So then what we did is that we gave to each symbol kind of nickname to be easy to easily name it. For example, this gamma somewhere. Yes. So gamma, we gave it the name, the nickname gamma. Okay. And this is about 120 different symbols. Okay. It would be some kind of complex cipher because we would have only say 26 Oh, yes, I say the French, but because our guess was that the letter was in French, because the clear text was in French, but it could have been in German, in Latin. So Charles V was speaking different languages. And it was in French. Okay. So once we had this, the whole letter in the Python, so we each symbol into the Python encoding of the letter, from which we could do several analysis or do several guesses about the deciphering. We did is a frequency analysis. This is the letter. The corresponding frequency compared to Rabelais at that time. So Pantagruel is some book from Rabelais, and at the time, which differs from the frequency of modern French. So that's why we text from the time. Okay, so we see that in French the letter E is about 17%. It could be, for example, something like plus maybe a small one that could match. Okay. Which is basis from Philip II to his father to take at least three, to have at least three symbols for. On the other side, you consider this symbol, it's not a null symbol, then it cannot match the letter R. On that hypothesis, consider the 8 here. Then we try to match some repetitions in the text. Here, repetition of 5 symbols here. You can see another repetition of 11 symbols in red here, between this and this. When we found those repetitions, we were quite astonished, because if you have the same word, say, of 11 letters, that you encode, if for each letter you have very unlikely that you have such a repetition. So either the letter was not encrypted by Charles V himself, so he has a secretary. He gave the letter to the secretary has the secret. Okay. So, hypothesis that the secretary was lazy. So he had encrypted this. He has first encrypted this word, and when he goes to the same word 3 lines later, he says, "Oh, I have already encrypted this word, so I will use the same encoding." Interesting to have those repetitions. Here you have more repetitions, and that at the end of some of the repetitions we found, for some of them we have a plus at the end of the word. Okay, So one of the hypotheses that the plus could be S, which the plural in French. Okay. So eight. Okay. Graphs we had in the text, and we found that one of the big graphs, first on the gamma here, is on more interestingly, was already followed by the gamma. Yeah. Little French. What letter is always or almost always followed by the same letter in French? A, you know, it's in that case. Q, yes. In French, Q always followed by a U. And this was a U. Turns out to be not completely true, but almost. Okay, so then we work some smaller finds all symbols or a given symbol in the message. And for example, if we call this function on the set P, the symbol with a Z with the dot. So this is what we on this symbol. We find that it's the symbol gamma. We have 11 occurrences of the two letter symbols, one after the other. Okay, so this led us to the hypothesis. A Q and this will be a Q. And also we tried also other things. We kind of dictionary of that time on 8 would encode E, S, or U, or plus or S, and so on. We try to find some words with some of the symbols that dictionary. Okay. For example, for this word, you have 8 at two different places here. We have to find the same letter at these two different places here. Well, is a brute force. Finite number of possibilities for the encryption because we can have maybe 40 different meanings. G was the same letter in the same. We have only 24. There are some words like E. A group of two letters. And words for doubling letters. 40 to the 120. But it's still too large for the computer. of a dead end. But maybe he can test all this for the most frequent symbol. Okay. So only 11 most frequent symbols. So there are about 2 to the 39 possibilities. Okay, to test make an exotic. Give us much result. Maybe this will help us to decipher a few words in the text, but not the whole text. Okay, so at that time we are stuck on we are only working the 3 colleagues from with the 2 colleagues from my team on get some help. And we asked our historian colleague, Thierry de Zanclos, and she told us we should recipient of this letter. The recipient of this letter Charles V in France. Some letters from Jean de Saint-Maurice were in Besançon, which is not very far from Nancy. And okay, so we found the link to these letters, which were digitalized. Which by luck had exactly the same cipher. One of the so this letter from Charles V of Besançon. Yes, I forgot to say that there are some symbols with bar on the symbol. Oh, yes, that one. Here you have a dot on the right. Got some description of the text. With that hint, it was quite easy to find the. Yeah, so let's try to decrypt. Eight would be an N. Yeah. Encoding 2 letters, in fact. What we have not found. Here, for example, the M and the R, they encode P, E. So in some words are hidden in the text. Like in Arabic, you do not write letters, or it's literally Arabic. You use diacritics to encode the volume. Is that each was encoding 2 letters. Okay, so in fact, what turned out is that got some special symbols what we call complex symbols that encode both consonant and a vowel. And if the complex symbol is the M, for example, is a complex symbol. If it's alone, it will encode the P. And if it's alone, it's PE. Is a vowel E, which is the most frequent in French. Okay. Yeah. E is a O. You have a different rule for each vowel. So here that we were able to reconstruct. On the top row, you have some symbols. So they encode just a simple letter, either a vowel or a consonant. You have some complex symbols. So you have to interpret them as follows. Okay, so if it's a symbol alone, encode M. You have a dot above, followed by an I. Or under, it's a symbol. QU. So if you see a Z alone, it will mean yes. You have also symbols for pair of consonants. Yeah. So you have a special symbol for the King of England, for the King of Bohème. Pink is a different cipher we found in other letters, which uses slightly different encoding. There were two symbols which were not known at that time, and we deciphered one of them. With that table, you can decipher the two letters, two sentences. Okay, for those who do not read French, we're speaking of somebody with name Pierre Sposi, who was some kind of story, okay? And he said that when he came to the camp of rebels, said, among other things, to the king, he saw this sentence. We are quite excited because it was. Okay, so what is deciphering on the left in French? Yes, in this line, be a king. Okay, so okay, a king was dead at that time. Our colleague, to our historian colleague, and she thus no king was in that year. And afterwards, she found out that at that time, the year was not the same than now. So they did count the year after back. How do you call it? Easter. Yeah, after Easter. So there was a pre-Easter and the after Easter date. And in fact, 1547 and not 46 as written in the letter. And in fact, the part about the project of maybe I will skip that part. This was Pierre Sposi, and so he was speaking. So he said to François the Fifth, I want to kill Charles the Fifth. And I do not care about money. I do not care about being killed if Charles the Fifth is together. And then the King of France, François, as you like, but I don't want to be among this. I don't want to be involved in those things. So in some sense, it said, okay, if you want to kill Charles the Fifth, but I don't want to be involved. Then in the letter, so that sort of Charles the right. Okay, I'd like to know if it's a rumor or if it's really right that Pierre Sposi wants to kill me. So he gives all the he really wants to kill him. Okay, and that's the end of the deciphering, where they're speaking about all those things happening at Prague. Okay, maybe I will skip the part. Okay, so that's the end. Also, you see the ciphering. It was many people. So there was Jean de Saint-Maurice, the ambassador of the Fifth, so which was the recipient of was Marie de Hongrie, which was the sister of Charles V. Renaud de Granvelle here was using part in now Spain. Work, we are quite astonished, so it had a lot of covering in the media, so maybe you have heard about it. Media, but also otherwise. And so I will finish by my wife. We did some travel now the Danube, and we stopped in Vienna, in Vienna, and I tried to find some old letters. So it's funny to take pictures of very old letters. So this was one of the letters we took. Is exactly the same cipher. Plenty of things to decipher. And in fact, one of the things is that recognize the different symbols here. So recognize symbols are not okay for this kind of letter. So we are still discussing with colleagues working in this domain. Okay, that's all.
Okay. For interesting talk, are there any questions?
Curious about the story. So
Yeah.
it was a serious death threat. Is that what
No.
they uncovered, or
So-
they don't know?
We don't know. We did not find any. This was the first mention of this rumor, but we did not find any confirmation. I guess.
That pair of symbols that you thought was Q,
Yeah.
the Z, gamma.
Yeah, yeah.
You said it wasn't though. What, you know,
That's because okay, maybe I will take the key again. Gamma is a L here. Okay, so which is very common in French. That E. Exactly that.
And do they use the same cipher or
Yes.
there are some variants?
Yes, they use exactly the same cipher on a period of almost 4 years with different people. So now we have a corpus of maybe pages using the same cipher. So it's really
Also the case for the last digital.
oh yes.
For the last page.
Oh yeah, yes, of course.
I see.
Yes, now we recognize it. Yes.
Oh, I see. Okay.
Exactly the same.
But
Yeah.
I think you need some automatic to.
Yeah.
And had anybody deciphered any of these letters before? Well, I think people who knew the code hundreds of years ago.
There were people that knew that code, but they did not. So the letter we deciphered was not digitalized, so it was not accessible. And, yeah. Yes, some people did decipher some part of the Spiller code. Decipher the different names. Okay, all right. Yes, the difficulty is that part here. It's the different symbols, and it has the letter has a completely different.
So what are the were here to you?
Oh yes, the one. Of Champs-Élysées. Marie de Hongrie. Yeah. She was, yes, this was the symbol. Yeah. Maybe.
So who finds this decipher? Is it known?
We don't know really who devised this cipher.
Which I think it was from class real was
So yeah.
more or less.
Yeah.
He was a better player. He would have given them.
And also, did Brent also have a
Yeah, yeah, the other also cipher. What is very surprising for us is that a good cipher, but they were using it among kind of secret key cipher. So usually you use it only between two people.
I mean,
Okay.
yeah.